Dean and the Sunil. Today I am explaining about principle and application of gas chromatography. Basically, principle chromatography is a gas chromatography is a powerful analytical technique used to separating and analyzing the compound in a gaseous state. It is widely used in various fields, including environmental analysis, food safety, and parametrics. Understanding the principle of gas chromatography can help in optimizing its applications across the different industries. Here we can see the diagram of gas chromatography. Principle of gas chromatography. Basically, gas chromatography operates the principle of partitioning and compounds between the stationary phase and a mobile gas phase. Here we can see the diagram. In liquid sample, simple injection unit means heat and vapor each components. In another one is columns. In another is detector. Here columns means separate compounds. It separates the compounds in liquid samples, and director which converts the amount of each component into an electrical signals. The symbol of vaporized and carries by the inert gas, typically helium or nitrogen, through a column. And different compounds interact differently with the stationary phase, leading to their separation as they travel through the columns. Components of the gas chromatography. Key components of the gas chromatography system includes the injector, columns, detector, and the data processing system. The injector includes the sample of the systems, while the column is where separates the occurs. Detectors such as flames, optimization or mass spectrometry identify and qualify the separate compounds. Here we can types of columns used in gas chromatography. Two main types of columns are used in gas chromatography: packed column and capillary columns. Packed columns are filled with solid stationary phase, while capillary columns have a thin film of liquid stationary phase lining the inner wall. The choice of column type can affect resolution, speed, and sensitivity of the analysis. Operating condition in gas chromatography. Key operating conditions include the temperature, flow rate, and pressure, which can significantly influence separation. Temperature is controlled to optimize the analysis to enhance separation efficiency. The carriage gas flows rate affects the time compound takes to travel the column, impacting resolution and analyzing time. Detection methods of gas chromatography are commonly detection methods include flame ionization detection, like it's called a FID. Mass separation means CMS. FID is sensitive to hydrocarbons and provides quantitative data, while MS offers structural information about the analytics. The choice of detection method depends on the specific requirement of the analysis begins performed. Calibration and qualification in gas chromatography. Calibrations is essential to quantify the concentration of analyte in a sample using standard solution. The calibration curve is created by plotting the detector response against known concentration of the analytic. Accurate quantitation requires careful preparation of standard and consideration of the matrix effects. Application of environmental analysis. Gas chromatography extensively used for analyzing pollutants in air, water, and soil samples. It can detect volatile organic compounds, shortly called as VOCs, that pose risk to human health and environmental. Applications including monitoring of industrial emissions, water quality testing, and soil contaminant assessment. Applications in food safety. Gas chromatography is employed to analyze food products for additive contaminants and flavor contaminants compounds. It helps to detect pesticides, reduces and ensuring complying with the safety regulations. Gas chromatography is also used to analyze volatile compounds that contribute an aroma in the flavor profiles and food. You can see the food safety gas chromatography applications in pharmaceutical analysis. In pharmaceutical industries, gas chromatography is used to purify the testing and stability studies of drugs for marketing. It helps to determine the composition of complex mixtures that identify the impurities. Gas chromatography plays a role in the development of new drugs by analyzing the reaction products and intermediates. Advantages of gas chromatography are we have so many advantages. Gas chromatography offers high sensitivity of resolution, making sustainability for a trace analysis. The technique is relatively quick, allowing for the rapid analysis of multiple samples, and its versatility unable to analyze of a wide range of compounds from gases. Conclusion for the future trends means the gas chromatography remains the essential tool in a modern analytical chemistry with diverse applications. Advantages of technology such as miniaturizing and automation are enhancing its capabilities and accessibilities. Future trends may include the integration with other techniques such as hypernated methods like gas chromatography MS for even greater analytical power. Feel free to adjust the content needs, the clarity or the specific presentation requirement. Thank you for giving this opportunity.